everyone. Today we are going to talk about enterprise authentication in Percona Server for MongoDB. My name is Sandra Romanchenko and I am QA engineer at Percona. So let's start from what is Percona Server for MongoDB? It's a solution based on MongoDB Community Edition with extra features and functionality built on top of it. So here on the slide, I've added a small comparison table of features available in Percona Server and in Enterprise Edition. Besides community features, we have added such functionality as LDAP authentication and authorization, Kerberos authentication, auditing, log reduction, data trace encryption. We have our own in-memory engine and also hot backup, which isn't openly accessible in enterprise version, but implicitly available via Ops Manager. So why access control is so important? I think that this picture, which is one Google search, can say more and louder than 1,000 words. Nowadays, when security topics are extremely popular and important, and even tiny companies have their own security departments, there are still unprotected databases which anyone can access and just gather private data. So what we can do to prevent unauthorized access? We can enable authentication, which is basically the process of verifying the identity of a client. There are several mechanisms available in Mongo database, and the first one is CRAM. It's a default one. It supposes using username and password. The second one is X59 certificate authentication. I think it's self-descriptive. Just please note that for using this method, secure SASL connection is required. That's all for Community Edition. If to talk about Enterprise Edition and Percona Server for MongoDB, there are also LDAP authentication, Kerberos, and new in 4.4, it's AWS IAM. It's not supported by Percona Server for MongoDB yet, but we have it already in our roadmap. So you may wonder, why to use LDAP or Kerberos if there is a default authentication mechanism and you could just use username and password? So there is no problems with that, but you will get a list of benefits if you switch to new methods. The first one is an ability to maintain all users in one place. It's not so important if you have, for instance, just DBA or developer who needs an access to database, but imagine a situation when there are a lot of people within different departments, let's say support, sales, development, marketing, and all of them need access to database with different permissions. And it really sounds like a nightmare for DBA who needs to manage all those users, to add them and remove records when access is no longer required. But with using LDAP, it's possible to do it just in one place. Also, it's possible to force users to follow your security policies, such as password lengths, complexity. You can set expiration for your account or password. You can even lock account in case of exceeding the number of login attempts. So let's check a little bit insights of centralized authentication. And the first one is LDAP proxy authentication. So the diagram shows all steps of the process. It starts when client sends plain authentication against Mongo server, and in its turn initiates SASL session with the client. Afterwards, Mongo client sends SASL authentication to Mongo server, which forwards it to SASL daemon, and it sends it to LDAP. When authentication is successful, the proof is returned all the way backwards. Sounds quite complicated. In addition to that, this method has its own limitations, restrictions, or maybe disadvantages. For instance, there is an external component, SASL daemon. We need to maintain it, we need to configure it, we need to ensure it's up and running as it can be an additional point of failure. But the main disadvantage is the necessity to add users in Mongo database, the same users that we have already in LDAP. This restriction is dictated by the fact that despite we successfully check user credentials, we still have no idea what permissions users should have. That's why we need an ability to match username to some permissions. I will show a bit later what exactly I mean in live demo. The second method is native LDAP authentication and authorization. This mechanism excludes all minuses of the previous one. So now we avoid using excessive components, and Mongo database communicates with LDAP directly. But the main benefit here is authorization. It means that when user tries to access Mongo database, it's not only checks user credentials, but it also checks to which group user belongs. And when group is returned from LDAP server, Mongo can match this group against some role which was previously created by admin. It means that it's still required to create corresponding roles with proper permissions in Mongo database, but the number of records is just significantly reduced. All you need is to divide your users into different groups and create roles in Mongo server. Then you can add as many users as you want in LDAP. You just need to assign a proper group. That's probably all. In addition to that, user can belong to different groups. It means that users' permissions will be merged. So user will receive permission from both groups together. And the last authentication mechanism is Kerberos. If you may know, Kerberos is a ticketing system. So in order to log into database, first of all, you need to receive a ticket from KDC. Afterwards, when authentication request is sent against Mongo server, which is also, by the way, Kerberos aware, Mongo validates this ticket against KDC. When and if a proof is returned, this proof is then sent to a client. That's probably all with theoretical part. So now let's move to a practical one and ensure that everything that I have mentioned actually works. So I will start demo from the first discussed authentication method, which is LDAP proxy authentication. I have pre-configured test environment with LDAP and Kerberos services since configuration of these services is just out of scope of this presentation. In order to use Mongo together with LDAP via SASL OSD, first we need to install SASL packages. Depending on operating system, you might use one of the provided commands. The next step will be a configuration of LDAP authentication mechanism for SASL OSD. And just for convenience, we enable automatic start of the service during system start. The next step will be a creation of configuration file for SASL OSD, where we provide the connection string to local LDAP server, together with bind distinguish name and password. In addition to that, we also need to set LDAP search base and LDAP filter, where basically the username is passed. Now we need to check whether our connection is successful. For this purpose, we will use test SASL OSD utility. We just need to pass it username and password of the user which already exists in LDAP. As we can see, connection is successful. So we can proceed with configuration of Mongo service. The first step in this case will be configuring SASL library for Mongo. We need to create a special mongodb.conf file in directory where SASL library can find it. In our case, it's etc. SASL2 directory. Here we just set regular options like path to run directory of the daemon. Next will be a configuration of MongoDB itself. We need to change in MongoDB conf authorization option and set it to enabled, and also add plain to authentication mechanisms option. In this case, plain stands for LDAP. Now we need to log into server and add the respective user. So we log into server as DBA and check just connection status to see what authentication roles were assigned. Now we need to switch to $external database, just in case it's not a real database. It doesn't store any data. It's kind of logical database which just instructs MongoDB that user is authenticated to an external service. So we switch to this $external database, and now we need to create a user. So we have added a user, test user, with permissions. In this case, I have added read permissions to test database. And that's all for Mongo configuration. Now we can try to log in to Mongo server. What we need to enter here is username, authentication database, which is $external, and authentication mechanism, which is plain. So let's try to log in. We need to enter a password. And login is successful. Let's try to check connection status. As we can see, correct permissions were assigned to a user. Now let's try to show a list of available databases, switch to test database, and check some data in test collection. All actions are successful. Now, to ensure that permissions work correctly, let's try to drop some data from test collection. And as expected, we receive an error since we do not have such permissions. And that's all for this, this authentication mechanism. So now let's move to native LDAP authentication. So in order to use native LDAP authentication, there is no need to configure any extra services or create some extra configuration files. All we need is to define proper options in Mongo config, and it will just work. Let's check out. So I have prepared the proper config file, and now I replaced the default one and restarted service using systemctl. So let's check out what's the proper config file. Here we see authorization option, which should be set to enabled as in the previous sample, and new section called LDAP, which contains the following options. Servers, it's either domain name of your LDAP or IP address. The next option is transport security. By default, it's set to TLS. So if you want to disable it, you need to explicitly set it to none. Also, it's possible to define bind user together with password. Please note that you need to provide here a full distinguished name. The next option is user to DN mapping. By the way, we have a cool blog post about it on our website. So if you're interested in peculiarities, you can check it out. Basically, this option is required for cases when user enters a convenient username during login. So we do not force users to enter a full distinguished name like CN equal Mongo, DS equal Percona Database, etc. We want users to enter something simple, for instance, just Mongo, but we need somehow to change it to full distinguished name. That's why we have this option. There are several possibilities. We can just change the value based on what we receive, or we can query LDAP. So whatever user enters, we send it to LDAP, asking whether there is such user or not, and asking us to return a full distinguished name. And the last option is query template. Here we query LDAP and ask to send the list of groups to which user belongs. And here we provide basically the user, which was the username, which was transferred and translated here. So let's try to log in. As in previous sample, just enter the username, which is test user, authentication database, and authentication mechanism, which is plain. So we enter a password and connection is successful. So let's check out connection status. As we can see here, the user is authenticated successfully because basically there is such user in LDAP and we have entered correct password. But on the other hand, the user doesn't have any permissions assigned in Mongo itself. So as we can see, user belongs to CN group, but this group doesn't match any role created in Mongo itself. So let's check out whether we can do, for instance, list databases. No, we can't. So now we need to log in again as DBA and create a correct role. So here we create a role which match the full distinguished name of the group to which user belongs and provide some permissions. For instance, in this case, we add built-in role, which is read, write any database. And let's check whether it will help us. So the same command, enter password. And now if we check connection status, we can see that we have received new permissions to read, write any database. And let's check whether we can actually do it. And we can. We can switch to test database, query data, whatever. So that's all configuration of native LDAP authentication. And now let's move to Kerberos. So the last is Kerberos authentication. The configuration is quite straightforward. All we need is to remove all previous configuration files and to add proper configuration to MongoDB conf. I will show it a little bit further. Also, the important point is to add a key tab for MongoDB. A key tab is a file which contains a pair of Kerberos principals and keys and can be used by remote system without entering a password. So it totally suits for services. A key tab should be defined in environmental variable, which is Kerberos 5 KT name, which in its turn should be set in etc. default MongoDB file. Now let's check MongoDB. Here we need to set authorization option to enabled and add GSS AP authentication mechanism. Now we need to log into Mongo server and add user with respective permissions. As in our previous case, if we authenticate using Kerberos, we still wouldn't know what permissions user should have. So again, we need to switch to $external database and create user, test user with in this case, root permission to admin database. Now we need to get a ticket for test user since Kerberos is a ticketing system. So we issue key init command for test user. We're receiving a ticket and enter a password. If it's successful, a ticket will be issued. And now we can try to log into Mongo server. Here we define authentication mechanism, which is GSS AP, and $external database, and username, which is test user. So let's try to log in. Login was successful. Let's check connection status. We can say that proper role was assigned to a user. We can check list of databases. All seems to work. So that's basically all what I have for now. I hope that for today's presentation, you will get some useful examples and tips for further configuration of your Percona server for MongoDB together with LDAP and Kerberos. Thanks for your attention and join us at Percona Live Online in October. Bye.